video, we're going to learn about plane mirrors. We're going to use ray diagrams to predict where and how images will form in plane mirrors. We're going to see the characteristics of image in plane mirrors as well, and we're going to learn about some applications of plane mirrors. As a reminder, there are two main types of mirrors we're going to study in optics in grade 10, plane mirrors and curved mirrors. Curved mirrors are ones that are curved. They can either be concave, where you curve inwards, or convex, where you curve outwards. And the plane mirrors are the ones that are flat. And this is the one that we're going to start exploring. We're going to be using ray diagrams. Ray diagrams are scientific diagrams that illustrate how light interacts with a certain mirror or object, and we're going to use those ray diagrams to help us find the images. So here you can see an example of an object in front of a plane mirror, a flat mirror, and a ray diagram is used to help locate where that image is going to be. And you can see that there's an eye symbol here to indicate how the eye will view that image. And so we're essentially going to see how to create these type of diagrams. Before we go into actually drawing, we're going to go over some terminology that you have to understand for the optics unit. A lot of this terminology will be the same throughout every type of mirror that we see, and even in the lenses as well. So the entity or the thing that's in front of the mirror is going to be the object. So here we have a tomato that's in front of the mirror, and that is the object. This is the plane mirror over here, and then the reflection that you would call it normally, that's called the image. So that's what's made by the mirror or perceived by the person. You can measure the distance of the object to the mirror, and that's called the object distance. That's called the DO. You can measure the height of the object. That's called the object height. That's called the HO. You can measure the distance of the image to the mirror, and that's called the DI, image distance. You can measure the height of the image. How tall is the image? And that's called the image height. That's called the HI. So when you see those on diagrams, DI, distance of image, DO, distance of object, HO, object height, HI, image height, and I usually represents image, O usually represents object. And then there's also what's called orientation or attitude. That's basically, is the image upright or inverted? So think of it this way. This is the top of the tomato here. This is the bottom. The top is still facing up, and the bottom is still facing down. So this is upright. If the image was such that the top was now facing down, that would be inverted. So that's an inverted attitude or orientation. So images in different mirrors could be upright, where the top still faces the top, or inverted, where the top now faces the bottom. So it's the opposite, it's almost flipped top to bottom compared to your object. And we'll see that for other mirrors, not necessarily plane ones, but other ones. There's also something called virtual image versus real image. That's a type of image. So images that are made with these rays that happen behind the mirror, those are called virtual images. They're in the mirror. So just to give you some more context, this here would be an incident ray, this here would be a reflected ray. Your eye would be over here, and your eye doesn't realize this reflection is happening. So it believes that the image, your eye, and I should say your brain believes the image is made by rays that exist behind the mirror. Your brain basically doesn't think there's a mirror here, and simply thinks there are rays coming here. These rays are not real. These rays are not real. They are virtual rays or imaginary rays. They are called traceback rays. They're represented as dotted lines behind the mirror. So they're not real rays. Because they're not real rays, and their image is formed by rays that are not real, that are tracebacks, we call them, tracebacks of the reflected ray. You trace it back from the reflected ray. We call that a virtual image. Some images are real images. They're made by actual rays that will cross and meet, and that's what your brain sees. And so some mirrors will produce that. And we'll see that when we get there. So main idea is that images can be described based on their height, based on their distance from the mirror. They can be described based on their orientation or their attitude, we call it. And they can also be described based on the type of image that you have. Now for plane mirrors, we're going to see that really for type it's always virtual, and for orientation it's always upright. Where it will be a little bit different is when we get to curved mirrors. All right. So how do we describe an image in optics? In optics, we can describe an image using two systems, the loss system or the salt system. If we use a loss system, we have LOST. L is location. You're essentially just comparing your DO and your DI. So the object distance and the image distance. Are they the same? Is the object distance larger, smaller? And you can measure that with a ruler. You can measure from your object to your mirror and from your image to your mirror. And you can compare the two, DO and DI. The O in LOST is orientation. Is the image upright or inverted? So you can see here the arrow points up. The arrow still points up. It's not pointing down. So this image would be considered upright. So that's the orientation. You can describe the size. The size just means how does HO compare to HI. So you can measure HO, you can measure HI, and compare them to each other. And then the type. Is it real or virtual? So if it's made by traceback rays, it's virtual. If it's real rays, it's real. You can also use the SALT system. Describing an image with SALT is essentially the same as LOST, just a different order. The S in SALT stands for size, HI versus HO. The A stands for attitude, which is the same thing as orientation. Is it upright or inverted? The L, location, DI versus DO. And the T, type, virtual versus real. So it doesn't really matter which one you use, LOST versus SALT, you're still given the same information regardless. All right, so before we go into actually draw plane mirror array diagrams, let's take a look at the characteristics that we're going to see for plane mirror images. If we know the characteristics ahead of time, we know if our diagram is going to be correct or not. And we're going to prove those, we're going to show that those characteristics actually happen with ray diagrams. So here we have an object in front of a mirror, and here we have the image that's made. What you'll notice is that the height of this object will actually be the same as the height of this image. So when you have a plane mirror and you're looking at size, HI is always equal to HO. If something is 5 centimeters tall, the image will be 5 centimeters tall. In terms of the orientation, the head is still up there, not at the bottom for the image. The head is still on top here. So that means that the image is always going to be upright in terms of orientation for plane mirrors. Location-wise, if the object is 5 feet away, the image is also 5 feet away. So DI is always equal to DO when it comes to the location for plane mirrors. And lastly, type, the image is always virtual. So plane mirrors, their characteristics, they're always kind of the same thing. DI is equal to DO, orientation is upright, size, HI is equal to HO, and type, virtual. The image appears to be behind the mirror because it's made by traceback rays. So it's important to remember these characteristics because they will be useful in helping you be more certain of the answers when you draw your actual ray diagrams. So our next step is to be able to draw a ray diagram to find the image of an object in front of that's placed in front of a plane mirror. And so all the steps are listed over here. In order to do this, you're going to need a protractor because you'll have to measure angles of incidence and angles of reflection. You're also going to need a pencil, a sharp pencil preferably. The sharper your pencil, the neater your diagram can be, and the easier it's going to be for you to decipher what's happening in your diagram. But essentially, you're just going to use incident rays and reflected rays and traceback rays to find the location of where your image is going to be. So in this video, we had a brief introduction to plane mirrors, what they are, what the image characteristics are, terminology, how to describe image characteristics using LOST and SALT. In the next video, we're going to take a look at some examples of drawing ray diagrams for objects in front of plane mirrors.